Assalamualaikum warahmatullahi wabarakatuh. Welcome to the third video lesson for physics. So we are still in topic 2.3, which is free fall. In this video lesson, we will look at something that is called terminal velocity. So for the first lesson, we looked at what is free fall. And for the second lesson, we looked at what is air resistance. Now for the third lesson, we will finally touch upon terminal velocity and what happens when things are actually falling. So these are the lesson objectives. At the end of this lesson, these are the things that you should be able to understand or to be able to recall. So the first objective is identify the terminal velocity of a falling body from a speed time graph. The second objective is describe qualitatively the motion of bodies with constant weight, falling with and without air resistance. And the last objective is you need to know how to explain the forces acting on the falling object. Let's start. Right, so what is terminal velocity? So let me just explain a few things first. Number one, when an object falls through a long distance in air, the effect of air resistance needs to be considered. So the difference between objects falling with a short height and with a longer height is that for a short height, because the fall is very short, it's quite a quick fall, so air resistance don't really affect the object that much because it's falling quite quickly. But when you are falling from a greater height, then you need to take into consideration the effect of air resistance, and this is what we are talking about today. Number two, for falling objects, the speed of the object will increase, and this will cause air resistance to increase as well. So in the second video, we talked about the factors affecting air resistance, and one of the factors is speed. So it's quite logical. The faster you go, the more air resistance you will feel. So you experience this in daily life. So if you are moving faster, you can feel the air rushing through you. You can feel the air pushing against you stronger. Number three, at one point during the fall, the air resistance will be equal to the gravitational force on the object. So if you look at this diagram, right, on the right here, so you have a falling object, right, which is that circle there. And when an object is falling, gravity is acting on it, and also air resistance is acting on it. But as the object falls, it becomes faster and faster, and eventually, and it falls faster and faster, and the air resistance will increase larger and it gets larger and larger. So at some point, these two forces will equal, and number four, when this happens, the object will no longer be accelerating and will fall with steady speed. And this is what we call terminal velocity. So we'll talk more in depth and in detail about this in the next slide. But for the time being, know that this is what the forces look like when things are uh, falling in the air, right? Number five, when an object is falling at terminal velocity, it is falling at its maximum speed. So what does that mean? Let's look at this graph we have at the bottom here. Okay, so this is a speed time graph, and this is what it looks like when you are falling in the air. So in the beginning, the first part of this graph here, when you are falling, your speed, because you are falling, therefore your speed is increasing. You are getting faster and faster, you are accelerating. And then at a certain point, your speed is still increasing, but the way that it increases is getting smaller and smaller. So that's why the graph starts to curve here. Okay, your speed is starting, you are still speeding up, but your acceleration is getting smaller and smaller. And if you remember from our previous lessons before the holiday, the gradient of the graph is equal to the acceleration. right? So the first part of the graph, you have constant acceleration. It's a straight line. And then the second part of the graph, you have your acceleration decreasing. Okay, I hope you still remember your graphs, how to interpret your graphs. So the first part, you have constant acceleration, your speed increases quite rapidly. The second part of the graph, in the middle part here, you're still increasing in speed, but your acceleration decreases. And then after your speed has increased at a certain point, your speed will no longer increase and it will become constant. So at this point here, when you have reached this point of the graph, this is what we call terminal velocity, right? So the word terminal in terminal velocity, that means, so the word terminal means that's the stopping point for velocity. The speed of velocity no longer increase from that point onwards, and that's what we mean by terminal velocity. That's the maximum speed that it will reach. So you can see here on the graph, when you reach terminal velocity, your speed is constant. That's why the graph is a horizontal straight line. That means on a graph, if you have a horizontal straight line, that means the speed is constant. So during terminal velocity, the speed is constant. All right, so here in the next slide, you can see two different graphs of two different objects falling and reaching terminal velocity. So you have the green graph for object number 1, and you have blue graph, which is object number 2. And you can see, even though these two objects are falling, they are falling with a slightly different motion. So the object number 1 with the green graph has a higher terminal velocity. So you can see the horizontal line is slightly higher than the blue graph, right? So let me just give you numbers here. So let's say that's 100 meters per second square. And the one for the blue graph, that's 50 meters per second square. So if I ask what is the terminal velocity for object number 1, which has the green graph, yeah, you can say the terminal velocity of object number 1 is 10 meters per second. 10 meters per second. And for object number 2, with the blue graph, the terminal velocity is 50 meters per second, right? So if you have a higher terminal velocity on the graph, it will look like this. So the horizontal line will also be higher. Right, so for this next part, we will actually talk about in detail what is actually happening when something is falling at a really high altitude. Okay, so imagine yourself. So we're gonna talk about skydivers or skydiving for this part here. So imagine yourself a skydiver. Imagine yourself jumping out of the plane. What are the forces acting on you, and what's gonna happen to your motion? Will you speed up or will you slow down? What's happening to your body? What are your speed and so on? Okay. So when you jump out of a plane, what will happen first is, as soon as you go out, gravitational force will be acting on you. So on this part of the graph here, this is you falling, and the only force in the beginning, the only force acting on you is the gravitational force. And what does that look like on your graph? On your graph, it looks like this. So this is a speed time graph. Because you only have gravitational force acting on you, you will accelerate. And as you know, if things are free falling, it will have an acceleration of 10 meters per second square. So in the beginning, your acceleration will be 10 meters per second square, and it will be a constant acceleration. And your speed will increase dramatically. As you are falling, you are getting faster and faster, and the air resistance will start to take effect on your body. So as you fall faster and faster, remember, speed it affects air resistance. The faster you fall down, the more air resistance you will feel. So you will feel a resistance, and because there is a resistance, your acceleration will start to decrease as well, right? So your acceleration now is no longer 10 meters per second square. It's an acceleration that is much lower than that. So on the graph, your speed is still increasing. You are still getting faster and faster, but the increase is getting smaller and smaller, okay? Because the acceleration is also getting smaller and smaller. And then what happens next? So, like I said, you are still falling faster and faster. Air resistance, it is initially very small, but as you fall faster and faster, air resistance will slowly increase up until a point where the air resistance, the size of the air resistance is equal to the size of the gravitational force. When this happens, air resistance and gravitational force, when they are equal, they will cancel out each other and you will no longer have acceleration. Remember, if two forces are balanced or two opposing forces are equal, they will cancel out each other. You don't have resultant force, and therefore, if you don't have resultant force, you don't have acceleration. When you don't have acceleration, that means you are you're no longer accelerating, and that means you are falling at a constant speed. And during this point, this is when terminal velocity happens. So your graph will now look like this. You have constant speed, and your graph is now a horizontal straight line, and the acceleration is zero because the forces are balanced. Right, so the forces are balanced and you are falling and falling and you are getting closer to the ground, okay? And eventually at some point you will want to open your parachute in order to save yourself so that you won't die. So when you open your parachute, what will happen? When you open your parachute, this is what happens. Your air resistance will suddenly increase dramatically, and then what happens to your speed? Your speed will decrease dramatically as well. Okay, so why do you have a bigger air resistance? Because you have your parachute out this time, and your parachute has a large surface area. And remember, surface area affects the air resistance. So your parachute has a larger surface area, and therefore now you have a larger air resistance. So your speed will now drop, or in other words, your speed will now decrease, and you move slower and slower and slower. As you move slower and slower, what will happen to your air resistance? So your air resistance will also decrease. So eventually your air resistance will change from big, and you will get slower and slower and slower, and your air resistance will eventually become smaller and smaller and smaller. And at a certain point, again, your air resistance will be equal to your gravitational force. And when this happens, you will reach terminal velocity again. In other words, when these two forces are equal again, you don't they will cancel out each other, and you don't have there will be no resultant force, there will be no acceleration, and you will fall at a constant speed again. And on your graph, you will reach a different terminal velocity. This time, um, a terminal velocity for you falling with the parachute open. So you will get another constant speed on your graph. So you are falling with your parachute open and you are reaching the ground. So when you have reached the ground, what happens? When you have reached the ground, your speed will immediately fall to zero. So you will stop, and when you stop, your speed is zero. That's why the graph drops immediately to zero, and that means you have reached the ground. And this is what the graph looks like when you are falling. So make sure for your exams, make sure you know each part of the graph. This part, what does it mean? This part, what does it mean? This part, what does it mean? This part, and also that part there. You need to be able to describe what happens to the speed and velocity, acceleration, and describe the forces that are involved during that motion. this is the last slide for this topic. So to summarize what we have covered for the last 3 video lessons, so for this topic there are only 3 video lessons. So the first thing in the first video that you learn is an object is in free fall if the force acting on it is the gravitational force. We True free fall only happens when only gravitational force is acting on a falling object. But on Earth, because we have air around us, because there is air resistance, things falling on Earth are not actually truly in free fall. Okay, you can only get true free fall if you don't have air resistance, like for example on the moon or in space. The second part that you learn is when you are free falling, the acceleration due to gravity on Earth especially is always 10 meters per second square. So this number you have to remember for your exams. And then for this video, you learn what is terminal velocity. So when you are falling, your speed is increasing every single time, and then you will reach a maximum speed where your speed no longer increases. That is what we call your terminal velocity, or you can also call it terminal speed, but let's just use terminal velocity for your syllabus. Okay, so terminal velocity is when you reach your maximum speed when you are free falling. And then the last part that we covered is this graph here. So for this graph, make sure you know what happens for all the parts of this graph. So the first part, second part, and so on. Okay, so we have covered it just probably about 2 minutes ago. And that is pretty much it for this topic. Next topic, we will start a new one, which is all about forces and dynamics. So I'll stop there for this lesson, and I'll see you in the next video. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.